Okay, we're continuing then with probability. What I want to introduce to you next is some other definitions, and the first one is mutually exclusive events. So could you put the heading down, please? Mutually exclusive events to start with. Just carrying on from where we were last time. Last thing we had down was what independence meant in statistics. So now it's mutually exclusive events. And I want to do a Venn diagram, which we did last time, but the circles I'm going to put in aren't quite like last time. So they're my two circles, A and B, showing two different things. What's the main thing you notice from that Venn diagram compared with the ones we had earlier? They don't overlap, yeah, okay. A and B are two things there that are called mutually exclusive. They cannot both happen at the same time. So, if A and B are mutually exclusive events, what can we write down about that probability? The probability of A intersection B. Yeah, that's 0 because there's no overlap. So the probability of A and B is 0. That's happening both together. So there is no overlap. They cannot happen at the same time. Cannot both happen at once. And if you get events like that, where that intersection is 0, they don't overlap, they cannot both happen at once, those events are called mutually exclusive events. Now I want to take you back to a formula you have seen before. We came across a formula last time for this. Can anybody tell me how I would read that out in the brackets, the A something B? Union, yeah, that's right. That's the A union and B. And that means A or B or both. And from a Venn diagram, if we just draw the normal one with our two overlapping circles, A or B or both is anything in a circle, doesn't matter whether it's in the overlap bit or not. Can anybody tell me what the formula was for this A union B from last time? It should have 3 bits on the right hand side. Go on, it starts, yeah, probability of A.
Plus the probability of B.
Yep.
Take away the probability of A and B.
Yeah, A intersection B. That's right. Okay. That's what we had last time. So if I told you now that A and B are mutually exclusive, and I'm just going to put that down by ME. That's what the ME is going to stand for, mutually exclusive. So if A and B are mutually exclusive, is there any way we can adjust the formula that Tabby gave us a minute ago? So the left-hand side I'm going to stay the same. If A and B are mutually exclusive, can we? Yep, Will?
Just get rid of the last bit
Yeah.
of A union.
You just get rid of that bit there, that's right. A or B is just A and B added together because there is no overlap. So that statement is true only if the events are mutually exclusive. And it works both ways. If you know they're mutually exclusive, then this statement is true. Or if you know that statement is true, that means they're mutually exclusive. So it works both ways. And I think last time, when we had something like that that worked both ways, we put a double-headed sort of arrow, something like that. Okay, one of them implies the other, and it goes both ways around.